Hello everyone and welcome back. Today we're going to talk a little bit about MerkleTrees, what they are, and basically what they're used for in the context of Web3 projects, specifically NFT projects. You'll typically see these when it comes to projects that want to store, let's say you were doing a whitelist mint and you had a lot of addresses. The issue with that is if you're trying to store them on chain, it can get pretty expensive depending on what network you're using. So the solution people came up with was something called MerkleTrees. And for those who don't know, I do have an article that goes through pretty much everything that you need to know in terms of how to conduct a whitelist mint and what MerkleTrees are. I will drop the link to it so you can just check it out. But really what we want to think about when it comes to MerkleTrees is that it condenses an entire list of addresses down to essentially one address. And the way MerkleTrees operate is that you have this hash, which will be called the root. Every address that makes up this MerkleTree is called the leaf. And basically the way a MerkleTree works is you have to prove that that leaf or that address belongs to the root, and all leaves belong to the MerkleTree root. And in a nutshell, that's basically what it is. Like I said, I'll drop the link below in terms of going through what MerkleTrees do and how they prove it. But I want to jump right into the coding. So MerkleTree roots. First, what we want to do is we want to look at the library, the Solidity library called MerkleProof. It's what we're going to be using in our code. There are a couple functions that you want to be aware of. The most important one is the verify function. And it's basically, it takes in a couple parameters. A proof, which we'll get into in a second, the root, and leaves, which I already explained before. The leaf is basically the address, but you're gonna do something special to it. The proof, the best way to explain what the proof is it's basically the number of steps it takes for that leaf to track its way to the root. So typically what you'll see here is this is an array. And what you'll see is this array is going to be made up of other leaves that help it track its way to that root. And the bigger the MerkleTree is, the more likely that this is actually going to be a pretty big array, depending on how many addresses you have. But basically that's it. When it comes to the coding, again, for those who are new, you can find all of the source code for the lessons they do in the GitHub repository for CryptoCadet Academy. So let's get started with our code. In our Solidity file, let's create our contract. And some of this you're not going to need for the MerkleTree to work, but let's put it in anyway. Okay. Really, for now, all we need is, it's good practice to make sure we have a price in there. So let's go ahead and do a price. Let's say the public price is this. Oops. And let's say the whitelist price let's also add our URI. And then let's add this special value in bytes 32 called the Merkle root. And so we get rid of this error that keeps bugging us. Let's just add the constructor in there. That's good. And for those who don't know, the ERC 721A was made popular for its gas efficiency and super cheap mints. For the most part, it's not too different. But we just have to declare that. Okay, and I do need 2 more values based on this contract. I need a private constant. Okay, that should get it. Okay, so let's go ahead and just jump straight into what we need for our Merkle root. So when setting the Merkle root, we just need to give it bytes 32. Do the Merkle root, and let's say only owner. What's the issue here? Oh, oops. There we go. And in a later lesson, I'm going to show you how to actually get this Merkle root, because it is a little bit not complicated, but once you know how to do it, it's pretty easy. Let's set our get function. It can probably be external, but let's leave it for now. Okay. And what's up with this? Oh. So let's do that. That's all I wanted. And in order for this error to go away, we need to set the base URI or get a function for that. So let's add that too. And just a quick tip, if I knew if I had my entire whitelist set up before I deployed, which sometimes is the case, not always, I could do something slick by making both of these public. I could do something like set Merkle root, and let's add in a bytes 32. I could do something like that. If I did what I wanted to do, which was make this external, this would get an error. And the reason for this is, for those that don't know the difference between public and external, is when you are deploying a contract, the constructor doesn't have access to external functions. So that's one of the big differences. External is actually a little bit more gas efficient, but you do need to be aware that you wouldn't be able to use this in this context, because the reason why it says it's undeclared is because it's external. It doesn't recognize this. So if I change this to public again, it'd probably go away. Yep, it went away. So just a little quick refresher on public versus external. Now, let's jump into how do we check our proof? So we need a function to do this for us. We'll call it isValid. Oops. Returns Boolean. Okay, and here's where that MerkleTree library I mentioned earlier pops up. We verify, and remember it takes 3 parameters: the MerkleTree, Merkle root, and the leaf. Excellent. So now what we need is to implement this in our whitelist mint. So let's do that. We've got a function called whitelist mint. Make it payable. We don't need that for this. We only need to check. So we're using this isValid function. We're passing in the MerkleTree. And we're going to do this special CryptoCadet 256 is basically a encryption mechanism. That's the best way I know how to explain it. And it's the way you encrypt these addresses. So we do this ABI encode pact, and then we're accepting the address, and you're encrypting it with this CryptoCadet 256. And then let's give them an error message. Okay, perfect. And then from there, all we need to do we can check, since I went through the trouble of coding it, let's check the price too while we're at it. Times the quantity. And if that's all good, let's call this internal function SafeMint quantity. Okay, and that's literally all we need to implement on the Solidity side.